I bet you didn't know what dramatic and powerful eruptions the star in our sky is capable of. The most powerful solar flare in 17 years has now put scientists on alert. What has happened? Why is it important? And what happens next? The star that provides us all with life and heat could trigger an inferno on our globe in the near future that would affect us all. Power outages lasting for days, the complete collapse of communication networks, and huge displays of color in the sky would be a real nightmare. And possibly an end-time scenario for our entire civilization. On December 14, 2023, the Earth experienced an extraordinary astronomical event, one of the largest solar eruptions in the last 17 years. This solar eruption, classified as X9.4, belongs to the strongest categories of solar eruptions. Eruptions of this type are part of our star's normal cycles, but this time something was different, and it's disturbing. The outburst far surpassed most previously observed events. The intensity and size of an X9.4 outburst is about 10,000 times stronger than an average solar eruption and is equivalent to the energy of billions of hydrogen bombs. This phenomenon was not only an impressive spectacle on the surface of the Sun, but also had a significant impact on Earth. This time, we got away with it. Scientists measured an increased amount of particles in the atmosphere, but our globe was able to fend off most of them. However, no one can guarantee that this will always be the case. As a Category X9.4 solar storm, it can cause devastating damage to electrical equipment on Earth, disable magnetic systems, and completely disrupt the power supply. The eruption resulted in a massive release of radiation and energy that was visible on the surface of the Sun as an extremely bright flash. Thanks to advanced monitoring instruments and satellites such as NASA's Solar Dynamics Observatory, astronomers were able to observe this event in extraordinary detail. This resulted in captivating images and videos that show us the violence, the beauty, but also the unpredictability of our star in a breathtaking way. An enormous plasma cloud ejected from the Sun traveled through space at incredible speeds of millions of kilometers per hour. Within just a few minutes, the particles of such an enormous event reached our globe. The direct effects of this solar eruption on the Earth were manifold. Although the Earth's atmosphere was able to absorb much of the harmful radiation, the interaction of the coronal mass ejection with the Earth's magnetic field triggered a geomagnetic storm. NASA issued a warning to power companies and airlines immediately after the event. Tension was high. Airplane flights were postponed by an hour as a precaution. Power companies prepared for outages, and global communications companies monitored their satellites. Everything remained calm. Only some people in certain regions of the world were able to enjoy the colorful aurora. This spectacle of light, which is usually only seen at the North and South Poles, suddenly lit up the sky in many other regions of the world. This event was not only an impressive natural phenomenon but also an important moment for science. It provided a rare opportunity to study the dynamics of solar eruptions and their interactions with the Earth's magnetic field. The findings from this event will help us protect ourselves even better in the future. Because it's only a matter of time before the Sun blows even more violent streams of particles in our direction. Protection for the Earth, solar research. Let's take a look at the history of solar research for a few moments. Around 100 years ago, solar research was still mainly based on earthbound observations with telescopes. At that time, many aspects of solar physics were still unknown. Astronomers observed what we know today as sunspots, solar flares, and the solar corona, but basically only saw an interplay of colors on the surface of our star that was difficult to define. The idea of the solar wind, a constant flow of particles from the Sun, had not yet been established, and no one knew anything about the solar plasma, the true origin of the auroras, or the heliosphere that protectively envelopes our entire solar system. In the 1950s, an American astrophysicist named Eugene Parker revolutionized our understanding of the Sun. He was the first to postulate the existence of the solar wind, a stream of charged particles that is constantly emitted by the Sun. This theory was initially controversial as it contradicted the ideas of the time about conditions in space. Parker's persistence and his detailed theoretical work on solar activity, which continued over the years, eventually led to Parker's work receiving the recognition it deserved. Parker's great triumph came in the 1960s when satellite measurements finally confirmed his theories about the solar wind and its influence on the Earth. Today, Eugene Parker is regarded as the father of solar research. After all, it was he who laid the foundations for the modern understanding of solar physics. Thanks to him, we know much more about the complex interactions between the Sun and interplanetary space, including the effects of solar storms on the Earth. And it's possible that this knowledge will save our entire modern civilization from collapse. After all, our knowledge of the Sun and violent eruptions is crucial for protecting space travel and predicting space weather events that can affect satellites, communications, and power grids on Earth. Our Sun, nourishing and deadly. When you think of the sun and sunshine, do you automatically think of a nice warm day, flowers, and light? Most of us automatically have a positive relationship with the sun, and that is basically true. Without the sun, there would be no light, no warmth, no flowers, no life, and the Earth as we know it would probably not exist at all. Without this very star, the sun is the radiant heart of our solar system. On a cosmic scale, our Sun is a rather small star with a medium luminosity. Nevertheless, the star is a power reactor of incredible proportions. Its mass accounts for more than 99.8% of the total mass of our solar system, and its size is so immense that about 1.3 million Earths would fit inside it. In its core, where temperatures of over 15 million degrees Celsius prevail, unimaginable nuclear fusions take place in which hydrogen is converted into helium. These reactions release an amount of energy that dwarfs anything on Earth. It's the engine that drives life and keeps the Earth in perfect balance. The sun is not only a source of light and warmth but also a symbol of hope and inspiration. It was sacred to our ancestors. The sun gods have always been the highest in many civilizations of this earth, and the greatest rulers of this earth chose the sun as a symbol to underline their claim to power. Its rays penetrate the darkness, bring color to our world, and influence the earth's complex weather and climate systems. Our lives are determined by the phases of brightness and darkness. We rise with the sunrise, and life comes to rest when the light of our star slowly fades. But the sun is more than just a shining celestial body. It is a dynamic and turbulent being, displaying wild activity, whimsy, and constant change. So close to the sun, Parker Solar Probe, SDO, and SOHO. Have you ever thought about how hard it is to study the sun? If you've ever tried to look directly at the sun, you know what I'm talking about. The sun's light immediately dazzles our eyes, so direct observation is only possible with special technologies. It's only in the last 100 years or so that filter technology and modern telescopes have made it possible to look directly into and at the sun. NASA and ESA's SDO satellite works with the latest filter technology for this purpose. The images of the sun's surface can therefore be seen in green, blue, or even red. The currently most modern solar observatory cleverly filters out the white and blue light waves from the images, providing breathtaking insights into solar activity. Every small crater, every surge, and every flash on the sun is made visible by the SDO. The news of the biggest solar storm of the last 17 years was brought to the world by this satellite. We must be grateful for this modern technology, and the SDO will certainly continue to warn us of devastating solar storms in the future. At the end of his long life, Eugene Parker, the solar pioneer, was able to see the solar probe named after him set off to explore his beloved star. The Parker Solar Probe is the first probe that will come closer to the sun than any other man-made object. Before it launched on August 12, 2018, the probe has since completed 2 close flybys of the sun. It is another groundbreaking technological advance and can fly directly through the sun's corona, thanks to sophisticated cooling and shielding technologies. In the vicinity of the sun, it gets even hotter regionally than on the sun's surface. The Parker Solar Probe defies high temperatures of up to 1,377 degrees Celsius in the sun's corona, takes measurements, and sends us images and tape recordings of the famous solar winds. The Parker Solar Probe's initial results have already been revolutionary, and over the course of its mission in the coming years, it will provide further unprecedented insights into the Sun's corona and the outer part of the solar atmosphere. The third in the group is the Solar and Heliospheric Observatory, or SOHO for short, operated by ESA and NASA. This solar observatory is located at the first Lagrange point, about 1.5 million kilometers from Earth, and has been observing events on the Sun from there since 1995. SOHO has also discovered more than 3,000 comets and protects our planet from cosmic surprises. Imminent, a devastating solar storm. Thanks to these solar observatories, we now know a great deal about the Sun. The findings are good, but they are also worrying. Because we know that the Sun is periodically prone to violent events, and it's precisely these that could pose a tough challenge to our civilization. If this gigantic event occurs, power grids across the globe could collapse within minutes. Sparks could fly from electrical equipment, and no technology would be able to react reliably. The collapse of communication systems would isolate us. No one would be able to phone America to ask what the situation is like there. Cell phones and smartphones would be disrupted. The internet would be gone. Electricity would be lost. Supermarkets would not be able to open. Air traffic would collapse. Banks would no longer be able to dispense money because ATMs would also be sparking. Don't believe it? What if I told you that this has already happened once? In 1859, there was a huge solar storm that put the first electrical systems, which were still brand new at the time, out of action. The telegraph lines vibrated, and sparks flew from the stationary equipment. Shades of red, orange, and yellow light could be seen in the sky in broad daylight. This event lasted for several weeks, with the first electrical installations being operational again after around a week. Only one British researcher discovered the true connections at the time. In his honor, the event was recorded in the history books as the Carrington event. And a storm like this could hit the Earth again at any time.